All right, ladies and gentlemen, welcome to Chapter 3. And Chapter 3 is a lot of work and review with fractions. So we're going to begin in Chapter 3.1, Lesson 3.1, with equivalent fractions and mixed numbers. So when we're finished with this section, we need to be able to identify, to write, to convert between equivalent fractions and mixed numbers. So in this particular, to begin with, we're going to determine whether fractions, which another term for fractions is ratios, whether they're equivalent or not. Now I'm going to review two of your options, although there are other options. And because we're dealing with fractions, I'm going to simply stick with fraction versions or ways of dealing with equivalency. So number one here is to put fractions into a common denominator format, okay, and then compare their numerators. Now, why is this the case? Well, I'm going to go forward by a slide and then come back. Going back to your third grade definition of fractions, we compare parts to wholes. So what I have here, and we'll just call these pizzas, I have two pizzas. On the left, I have a pizza that is broken into 4 equal segments. On the right, I have a pizza that is broken into 8 equal segments. And we will say that the missing piece up here, that is something that somebody has eaten. So somebody has eaten one of the 4 pieces here. Over here, somebody has eaten 2 of the 8 pieces on this particular one. And so the colored regions are the things that remain. And so what remains on the left is 3 out of 4. On the right is 6 out of 8. And so what we get here is a model idea of fractions. And when we're comparing them, in this case, is we're trying to decide how much area remains, or I guess if you want to go the other way, is gone, based on eating of pizza. And so we try to, using, at least in this model, is to realize that, oh, well, if I were to slide one on top of the other, you'll notice that the same amount of pizza is remaining or has been eaten out of each of the pieces of pie. And what our common denominator formats when we're adding and subtracting fractions, what we're doing is we're saying, okay, if I want to add what remains of this pizza to what remains of that pizza, well, I have to break their areas up into the same slice or size slices. In this case, one piece here is larger than one piece there. Well, that causes a problem with trying to put them together. But if I were to take the large pizza and I were to subdivide it a little further in a method like this, okay, if I were to cut those slices in half and realize that I now have 1, 2, 3, 4, 5, 6 slices of 8, and over here I have 6 slices of 8, and those pieces, the pieces here are now the same size there. I can put them together and I now have 12 slices of size 8, so 12 eighths, and then we get into our adding and so on together and comparing it. So what we're doing is we're actually taking the pieces, the slices of pizza, we're making them the same size so that we can put them together, okay? Which is basically what I'm doing here, is I'm saying, okay, if I put these into a common denominator format, one, the slices of my pizza are the same size, therefore I can compare them. The sizes are the same, are the same, so they can be compared. Now, common denominators, and you have choices in this case. Most people have brainwashed you into finding the smallest, and if you can, that is the best. But if you're ever stuck, just go 8 times 12 in this case. That will be a common denominator. 15 times 20 is a common denominator. May not be the smallest, but at least it's something that you can work with. Now, in this case, I know that 8 and 12 both go into 24, so I'm going to use 24. Okay, so 24ths. Now, 8 times 3 is 24. So I need to multiply my numerator by that same factor of 3. 6 times 3 is 18. Okay, now if I get 18 24ths over here, then obviously these are equal. Okay. 12 times 2 is 24. So the same factor, I have to multiply by that same factor of 2. 9 times 2 is 18. And you'll notice, yep, equal. So 6/8 is equal to 9/12. Okay, so that is one way that you can compare your ratios, your fractions. Option 2 for now is to reduce the two fractions to lowest terms. When they're reduced to the lowest terms, if you have the same fraction on both sides, they're equal. If you don't have the same fraction, they're not equal. It's that simple. And so let's go ahead, and I'm going to reduce these to lowest terms. I know that 18 and 15 both divide by 3. Okay, so I'm dividing these both by 3. 18 divided by 3 is 6. 15 divided by 3 is 5. So I have the fraction 6/5. Okay. Over here, I know that 25 and 20 both divide by 5. So I'm going to divide them both by 5. 25 divided by 5 is 5. 20 divided by 5 is 4. Okay, so and these are both in lowest terms. Are they equal? No, answer is no. So 18/15 was not equal to 25/20. Okay, because when I reduced them both to lowest terms, they were not the same. Now, yes, there are other ways that you can compare fractions, but for this particular video, I'm sticking with these two. We're going to keep fractions as fractions and go on with life. So, all right. So, going past my modeling, we're going to talk about improper fractions and review those and mixed numbers and converting back and forth. First of all, an improper fraction, which, by the way, there's nothing improper about improper fractions. The term improper makes it sound like there's something bad about improper fractions. There are not. Okay, it's just a term. Another term that you will sometimes hear for improper is top-heavy, because the top is bigger than the bottom, and you might think of it wanting to tip. But anyway, an improper fraction is a fraction whose numerator is larger than or equal to its denominator. Okay, there's nothing bad about an improper fraction, and 9 times out of 10, we try to think that mixed numbers are better than improper fractions, but most of the time when you use the mixed number, what do? Oh, you turn it back into an improper fraction. So sometimes the improper fraction version is actually better. So, a mixed number is a number that contains both a whole number and a fraction, and if you really think about this, when I read 1 3/5, 1 and 3/5, the term and basically is plus. So I actually have 1 plus 3/5 here to make up my number. Okay, and so we are going to, as we go along here, convert back and forth from, just review the rules of converting back and forth between improper fractions and mixed numbers. So now, the steps for going from improper to mixed is to divide the numerator by the denominator. And when we do fractional division, we do the numerator divided by the denominator always. The quotient, the whole number quotient, will be your whole number. The remainder will be the numerator of your fraction, your mixed number fraction, and I probably should have put step number 3 here. Your denominator, in this case 4, and in this case 5, will be the denominator of your new fraction. Okay. Now when I do this, I'm going to do the mental math way, and then I'm going to do the long division way. Over here I'm going to do the mental math way. Okay, so in my head I am going to go, okay, how many whole times does 4 go into 21? Well, I know 4 goes into 21 5 whole times, because 4 times 5 is 20. And again, in my head, I'm going to take 20 out of 21, and that will leave me a remainder of 1. There is my numerator of my fraction. I keep my denominator of 4, so 21/4 is 5 and 1/4 as a mixed number. Now for smaller numbers, mental math, pretty simple to do there. What if the numbers are bigger? And not that 13/5 is all that huge, but let's just say that you're not sure how many times 5 goes into 13. You can do the long division way. 13 divided by 5 and set it up. Okay, does 5 go into 1? No. Does 5 go into 13? Yes. How many times? 2. Okay, so 2 is my whole number. 5 times 2 is 10. 13 minus 10 leaves me 3. There is my remainder. And I will keep my 5, my divisor, as the denominator of my fraction. So 2 3/5 is my solution here. So if you need to, go ahead and do the long division method. Now we're going to go the other way. Okay, first I'm going to give you the steps. And this is actually the shortcut version. This is the version that mathematicians have found using patterns to establish the fact that there are quicker ways sometimes to do the mathematics if you understand the pattern. So first of all, we're going to multiply the denominator and the whole number. Then, whatever that is, we're going to add the numerator to. Okay? That solution is the numerator of your new fraction, your new improper fraction. You will keep the existing denominator as the denominator for your answer. So I already know beginning, or in A, 5 will be my denominator, and in B, 7 will be my denominator. Now if you want an example, let me slide this out of the way. Bring this out here. An example. So if I have 1 3/4, denominator times whole number, 4 times 1 is 4. That's what this part is. 4 times 1 is 4. 4 plus 3 is 7. So 4 plus 3 is 7. And keep my denominator. So now, let us go ahead. I'm going to go through the quick way. Actually, I'm going to go through the quick way twice, and then I'm going to show you one other thing, and then you will be off to do practice. 5 times 2. Okay, 5 times 2 is 10. 10 plus 4 is 14. So 14, and keep your denominator. 5 times 7 is 35. Plus 3. Well, 35 plus 3 is 38 sevenths. Now let me show you this as the why this works, or how this works. 25 plus 4/5. Because again, remember I said that whole and thing. Okay, what would happen? Because the example I gave you, that is the shortcut version. Here's the long version way. If I'm going to add these together, going through all of the steps, whole number plus fraction. Well, we have to take the whole number and change it into a fraction. So 2 over 1 is our whole number, or is our fractional version of 2. Well, in order to add fractions together, we know that we have to have a common denominator. So in this particular case, common denominator of 5. Well, the 4/5 is already a common denominator of 5. Multiplying by 5 to give me my 5 denominator. Multiplying by 5. 5 times 2 is 10. And if I add these together, 10 plus 4 is 14, keeping your denominator of 5, 14/5. Same thing over here, 5 plus 3/7. My whole number becomes a fraction by placing it over 1. Well, the common denominator of 1 and 7 is 7. Now the 3/7 I don't have to change, it's already in sevenths. I don't have to worry about that. But over here, I would multiply 1 by 7. So the numerator gets multiplied by the same factor. So 7 times 5 is 35. If I add those together, you'll notice 35 plus 3 is 38. My denominator is 7. And you'll notice, okay, so the steps that I'm giving you are the shortcut version for doing all of this addition and common denominator work and so on. So if we can memorize the shortcut version, it makes your life a whole lot simpler. That being said, 3 out of 2 people have trouble with fractions. Think about that for a little bit. Anyway, good luck with your fractions. Again, just like a lot of other things, they take practice. And once you practice and you get over the little hurdles, you'll be just fine. So good luck. Come see me for help. Have at it.